Yes, guys, the paper we were solving is part 2 of the paper, question number 5C onward, because the last video I made is from for question number 1 till 5, uh, part A and B of question 5. Now, this question C, it has been till here we have recorded, so the onward recording is going to start right now. Okay, let me repeat the question. The system has been in motion for 1.5 second. The string attached to a breaks. Okay, this was the already we have done. So for here, so we are doing the calculation here. The weight was particle A was 3 kg, so it becomes 30, and angle theta is what? Angle is given here, that is 30 as well. So 30 degree, mu, coefficient of friction, what is that? We know that here it was 0.423. We calculated 0.423, and R was W cos 30. So calculate this. We get F is equal to, on the calculator, is minus 26 Newton. This negative sign shows that it's coming down. So this is free fall when the string breaks, the particle A coming down. Now we need to find with which acceleration it will come down. As we know, F is equal to ma. So acceleration after it is when the string breaks, with which it comes down. Any free fall acceleration here, F is minus 2.6, and A is what? 3. M is 3, A. So A will be minus 2.6. It's 26, not 2.6, 26. You can calculate 26 by 3 meter per second square. So the explosion with which it will come back to rest. So now we see how much distance will cover when it's with explosion this and speed this. Find the speed with moves, string breaks. So it means S2as is equal to v square minus u square. So as it's coming from rest, here the figure was like this. It's pulley, and here, and then this from u0 for it will slightly come rest and goes down. So final become initial 2a is minus 26 by 3, as we are looking for. Finally it is will come instantaneous rest, it is given. So v is 0, down is 0 square, minus u become v, and that is 3 square. So you can see the S will be on a calculator. You will get the S as 0.519 meter. This is the distance which it will cover with the acceleration of minus 26 by 3, and in this downfall motion. So total distance we are looking for. So here total distance with the first distance when it goes up, that is 2.25, plus with free fall is 0.519. So you can add it, it will be approximately 2.77 meter. That is the final answer. I hope you got it. Okay, now the continuity of the paper with question number 6. The particle P moves in a straight line and passes through the point A at time t0. The velocity v meter per second of P at time second is given by this. You are given the velocity v is equal to 2t plus 1 power is 3 by 2 minus 2t square, where is lying between time is 0 till 3 including. Find the maximum velocity of P in the interval this. For the maximum velocity, we know we need to find dv by dt and equate to 0. Maximum, minimum, we already find the differential and equate to 0. So dv by dt is what? You can solve it 3 by 2. Differentiation rule is 1 by 2 times 2 minus 4t. So once you put this 0, so it will be 2 to cancel. We can get 3 times 2t plus 1 root minus 4t equal to 0. So simplifying it, 9 times 2t, I can rewrite like this, shifting this side, doing simplification square on both sides. 9 times 2t plus 1 is equal to 16t square. So 16t square minus 18t minus 9 equal to 0. This is a quadratic equation with respect to the variable t. So here you need to find t, and that must fall between 0 and 3, right? With a calculator or factorization or any method you can use, we have t is equal to 18 plus minus 30 by 32. That gives me 1t as positive and negative, so t must be 48 by 32. Here it will be 3 by 2, or it will be t will be 18 minus 30 is minus 12 by 32, ignored because it will fall out of the domain of the time. Negative t is not in part of the question. So v maximum will be when t is 3 by 2. So put in the question 2 times 3 by 2 plus 1 whole power 3 by 2 minus 2 times 3 by 2 power square. After simplifying directly, we can get V max is what? 3.5 meter per second. I hope it is clear. Simple question for 5 marks. Easy. Okay, now B part of this question. It is given that in the interval 0 to 3, the velocity P is always positive. Okay, velocity in the interval is always positive. Find the distance of P from A at the instant when P is moving in the maximum velocity. So distance for distance you need to integrate, and always positive. So always positive, we know it will be what? T is maximum velocity, we get T is equal to 1.5. Okay, so it means from 0 till 1.5, not in 3. I can substitute a limit and I can integrate the V. S will be 0 till 1.5. V was 2t plus 1 power 3 by 2 minus 2t square, and dt we can integrate this. So S will be 1 by 5. I wrote it by applying the integral. You can do it by yourself. 2 by 3 t power 3 limits 0 to 1.5. Upper limit minus lower limit will give me the answer 3.95 meter on the calculator. I hope it is very much clear to you guys. Salmon. The final question of this paper, the particle P of mass 3 kg is projected with a speed of 8 meter per second up a line of greatest. Yes, it's little tricky question, but let's sketch the diagram which will help us. Rough plane inclined at 30 degrees to the horizontal. So if it is 30 degree, so particle P, suppose P is here, its mass is this one, speed projected up with the speed of 8 meter per second up a line of greatest slope of rough plane which means there is friction force against the driven force. Okay, we can little draw it little up here P, because we need to resolve its components, so that's why. P is projected from point A as the plane comes to the instance rest at point B. Okay, here is point B. If this is A point, here it is B point, and it will be rest here. Use V is equal to 0 meter per second at this point, and is going till here, and we projected P then slides back to the okay. A on the plane and comes to instant rest is B, and P then slides back. Then it means it needs to come down here to A. The coefficient of friction is given to be, it means we are given the coefficient of friction, that is mu is root 3 by 12. Use energy method. Find the speed of which it instantaneous returns to A. Yani this speed we have to calculate. This speed at A we need to calculate what is with which speed it will returns to A. Okay, energy method. So we can say first we start from for the motion from B to A. Okay, take this from B to A. Downward motion, we know the work done by driven minus work done by resistive is equal to change in kinetic. It's coming down, so decrease in potential energy, so change in potential energy minus, I can use this relation here as it is coming down free fall, so driven force will be 0 here, and resistive forces, for that I need to resolve it into components. So this is weight components W, this will be W sine 30, and here it will be W cos 30, that is equal to the the R, the contact force. So we don't know what will be this height. We need to know this height as well and this distance as well. Okay, so by applying this, apply the values. Resistive force is what mu r, and that is supposed to be W sine 30 degree, sine 30 degree, right? Yes, so 30 degree is equal to change in kinetics half mv square minus u square coming down minus mgh. We have to calculate this. So let's substitute the value. Minus root 3 by 12. R is what? W cos of 30 minus W sine of 30. 1 by 2 mass is what? 3. And here V square we have to find, and initially it's coming from instantaneous rest. So at B 0, minus M is 3, G is 10, and H we have to calculate H, how much height it will attain while for the height. If we can apply this height we are looking for, angle is 30 degree, S we are looking for, and we have to find H, right? How can we find H? For H we need to find S first. So for the motion A till B, we know the driven force minus the force is your net force. So here for A to B, as there is no such force applied on as a driven force, so I can say driven force minus resistive force equal to net force for A to B. So no force given to us, and was only the speed which is throwing up, and resistive force will be mu r minus W sine 30 is equal to net ma. We are going to find the acceleration with which it is going to be decreased at the B when B becomes 0 and the particle becomes to be instantaneous at rest. So here minus root 3 by 12 and W cos of 30 value of R minus W sine of 30, M is 3 and A. We can see the calculator is minus 15 by 4. W is 30, right? Because mass is 3. 15 is equal to 3A. So A will comes to be minus 6.25. Negative sign shows it's decelerating because as it's going up and here the at point particle B, it will be at 0 because its driven force is not going to be applied on it. Only the speed with which it throws up with the 8 meter per second, it comes there. So this is and now we are looking for S of AB. SAB, how much distance is covered with while throwing with this, and the speed of U 8 meter per second. U was initially 8 meter per second. At B it was 0 meter per second. A we have calculated. So S distance for A B is V square minus U square over 2 time of A. We can calculate this. It goes to be 0 minus 8 square by 2 time. Let me write on next page. 0 square minus 8 square over 2 time of minus 6.25, and calculation will give us it's 5.12 meter. So distance for the point position A and B is 5.12. It means this is 5.12 meter. Distance will cover from A to B with throwing a velocity of 8 meter per second. Right, now it will make life easy. So here it is 5.12 S. So H will be sine 30 degree will be H over 5.12. So H will be 5.12 times sine 30. We can calculate it 2.56 meter height. So it is 2.56 meter. Now life will be easy. We can find B easily by substituting H here. So right, let me separate the page. Now I can substitute the values here. It will be minus root 3 by 12, and the W is 30 cos 30 minus 30 sine 30 is equal to 3 by 2 V square minus 30 times 5.12, that is H we have calculated. So simplify now. We can have 58.05 is equal to 1.5 V square. So V square will be 38.7. So V will be 6.22 meters per second. And this should be the final answer of this question. It was little tricky, but if you can resolve the question from the figure, it can make your life easy. Okay, good luck.